Hey everybody, in this video we are going to apply the difference quotient to the function f of x equals square root of x. But before we do that, we're going to make sure that we have a good grip on composition of functions, and then we're going to also get into rationalizing a numerator and cleaning up this messy thing that we're going to see in part 3b. So let's get started. So over here we have f of x equals the square root of x, and the first thing we want is to figure out, according to the directions, is the f of x plus h. Again, the purpose and use of all of this stuff going on in these problems can be found in the introduction video to the playlist that I will have pop up in a thumbnail at the end of the video, and I will try to put it in the description box. Okay? All right. So over here, I'm plugging in x plus h everywhere I have an x. So we're going to have the square root of, you guessed it, x plus h. Now, in the other examples we already did, there was quite a bit of simplifying we were able to do, but not really here. So just to reiterate, f of x plus h is equal to the square root of x plus h. So to use my color coding system, radical x plus h is the f of x plus h. Now the f of x, which we also need, is over here, right? It's the f of x is equal to square root of x. So we're going to go ahead now and fill all of this in. But don't forget that the h on the bottom is the, do you remember? Devil. Okay? That h on bottom, he's the devil. Right? And we need to get rid of him. Okay? So we're going to have to make sure that h crosses out at some point, reduces, simplifies, sayonara. Right? Okay. So let's get into it. So the... Is this writing for me? Here we go. F of x plus h minus f of x all over h will become the square root of x plus h minus square root of x all over h. Right here was the f of x plus h, which we saw in part A. And then here, f of x is right there, the original function. Now, again, this h in the denominator, he's the devil. And we need to get rid of him. He's got to go. But the only h he could possibly cross out with is inside of a radical, and I only really know one way to get him out of there. So I'm going to rationalize the numerator. So what I'm going to do is multiply by the conjugate. Hopefully everyone knows that word. That means we're going to multiply by x plus h in the radical x plus h plus radical x. And whatever we do on top, we're going to do the same on bottom. Because anytime you multiply on top and bottom by the same thing, you're really only multiplying by 1, which is totally legal. It just changes how things look. It doesn't change what they are equal to, right? So what I'm going to do is I'm going to use FOIL, or distribution more or less here, to multiply the radical x plus h minus radical x with the radical x plus h plus radical x. And that's what makes something a conjugate, is like when you conjugate the verbs in foreign language class, you keep the beginning and you change the ending. And what's going to happen is when we FOIL, the outer and the inner are going to be exact opposites, and they're going to cancel out. So let's continue. In my numerator, I'm going to have radical x plus h times radical x plus h. That's going to leave me really with radical, I'm going to erase this in 1 second, x plus h times itself, so squared. So that's going to leave me with radical, no radical, I'm sorry. That's going to leave me with x plus h. Now the outer and the inner are the exact opposites, so guess what? I'm not even going to write them. So then I'm going to have last times last which is root x times root x, one of which is negative, the other is positive. So I will get radical x squared, which is just x. So I will get minus x. If you don't get that, rewind it, play it again. I cannot possibly sit here and go through all those steps. It's just ridiculous. So then, bottom, don't distribute denominator, don't distribute the devil. We want that h to cross out, so we're going to leave him segregated and isolated, okay? Radical x plus h plus radical x. Now, what is going to happen next? Glad you asked. So next, I'm going to clean up my numerator, and this x can cancel out. Well, that leaves me with just, I don't even need this minus anymore, right? And that plus is really unnecessary also. So I have h over h times the quantity right there, right? So what can I do with the h? Well, the h and the h can reduce, not cancel. It's not zero, it's reducing. And what is it reducing into? Well, obviously it's reducing into 1. And then what's on bottom is just the radical x plus h. You might be saying, but I thought h was the devil. He's in the denominator. He's not quite the devil when he's in the denominator in this form. He's really the devil when he's being multiplied in the denominator, because h, we want h to eventually equal 0. And here I could not plug in 0. Oops, I'm cutting off that part of the screen. You can't see, can you? So h is eventually going to equal 0. And that can't happen right there, because if that happens, we're going to divide by 0 and our answer will be undefined. So I can fill 0 in for h here, right? And we'll talk about that in 1 second. So this answer right now, though, is the answer to the main problem at hand. That is the answer to the difference quotient. So right here, and you're done. But as mentioned, in calculus, you're going to take it further. You're going to take the limit of this whole thing as h approaches 0, because we're going to want h to get closer and closer and closer to 0. We're going to do direct sub, which we could not do until now. So if I fill in 0 for h, what will I get? I'll get 1 over root x plus root x, which is not x, it is 2 root x. And this right here is the derivative of the square root of x. So in calculus, that's the answer you're going to be finding. For right now, in pre-calc, we're really focused on composition of functions and the idea of limits, but towards the end of the year, we will get a little bit more heavy into the limit definition of a derivative. So there you go. Hope you enjoyed. Hope you feel smart. Hope you can practice that and get really good at it. And questions, comments, concerns, requests, or whatever, put it in the comment section and go ahead and check the playlist for more videos like this one. Bye for now. Adios.